Wow. Well, that video brings back some painful memories, but also some very fond memories. And I'm going to explain all that. So, hey everyone, I'm Ken Catania. I work at Vanderbilt University. And this video is a companion to my recent book on the art and craft of doing science. And these videos are a place where I can expand on a particular topic, maybe show you an interesting experiment or a cool animal behavior. And speaking of which, that video at the beginning was me being shocked by an electric eel in the course of doing some experiments. And if you're following along in the book, you'll know that I am holding up this particular experiment as part of doing normal science. And yet, it's one of the most bizarre and unusual experiments that I've done in my career. And trust me, I've done a lot of strange experiments. So how can this really weird experiment be part of doing normal science? Well, I've adopted the term normal science from the famous science philosopher Thomas Kuhn, who wrote a really influential book on the structure of scientific revolutions. And one of his key insights was that the sort of normal day job of a typical scientist is to solve particular puzzles in their area of expertise. In fact, he has a whole chapter on normal science as puzzle solving. And I'm going to read you a little bit of what he says there about solving puzzles. So he says, it requires the solution of all sorts of complex instrumental, conceptual, and mathematical puzzles. The person who succeeds proves themselves an expert puzzle solver, and the challenge of the puzzle is an important part of what usually drives them on. And as it turns out, that's a perfect description of what was going on with me during those experiments. I was very obsessed and driven by the challenge of this particular puzzle. So let me tell you what that puzzle was and why it fits so closely with Kuhn's description. So electric eels are one of the most amazing animals on the planet because, after all, a large part of their body is made up of a giant biological battery, and this generates hundreds of volts of electricity that they can use to either stun prey or defend themselves. And I was studying all this when I discovered a really intimidating defensive behavior. And I did not discover this using my own hand. I was using a metal net with a glove on, so I was safe, to move eels around. And when the eels were approached with this net, they basically explosively attacked by coming up out of the water to directly shock the metal handle. And so I'm going to actually show you this behavior, let the eels demonstrate it, using this prop arm that has a conductor on the side, and there's a bunch of LEDs within this arm that are powered by the eel. And when you see the eels attack the arm, I want you to think of those flashes as the nerve impulses for the pain receptors in your arm. So let me show this to you. Well, that's a very impressive defensive behavior, and I can tell you from personal experience that it's very efficient. But it's also really interesting for a number of reasons. For one thing, in the year 1800, a very famous naturalist, Alexander von Humboldt, went to the Amazon to collect electric eels, and he claimed that fishermen at the time herded horses into a pool containing electric eels. The eels emerged from the mud and attacked the horses in this epic battle, and then eventually the eels had exhausted themselves and the fishermen could collect the eels for Humboldt. Now that story was viewed with great skepticism. People knew electric eels, of course, attack prey and will eat relatively smaller things, but there was no evidence that they would go on the offensive like that against larger animals. So when I saw this behavior of the eels attacking conductors, it reminded me of Humboldt's story, and I did some research, and I was able to find an image that was commissioned by a friend of Humboldt that is one of the most detailed accounts of Humboldt's description of what happened. And right in the middle of that image, there's a horse being attacked by an electric eel, and the eel is coming up out of the water and pressing its lower jaw against the horse, just like what I was seeing in the laboratory. So I was ultimately able to publish a paper supporting Humboldt's account and essentially vindicating him, because this is exactly what electric eels do when there is a conductor, which would be a larger animal, in their territory and they need to defend themselves. Okay, so that's some fun background on electric eel behavior. And if you want to see the paper that links this defensive behavior to Humboldt's historical account, there's a link in the description below. And now I want to turn back to the concept of a puzzle. So what was I obsessed with solving in this case? Well, when an electric eel is swimming around in water, how its electricity interacts with prey or some animal that it may be defending itself against is really difficult to measure. That changes when the electric eel comes up out of the water to directly shock a threat. In that case, a relatively simple electric circuit forms. In fact, it's a lot like one of the problem sets in the back of an introductory physics book. So I want to show you that circuit and show you the variables. And it's not so important that you be into electric circuits so much as to recognize that there's a set of variables there to be solved. And each of those can be solved by either designing the right appropriate piece of equipment and conducting the right experiment, or by doing some calculations. Now, without really knowing it, I was essentially being a poster child for Kuhn's concept of what motivates a scientist to work on a problem. Now, of course, it doesn't have to be the case that you're fitting exactly Kuhn's description when you're puzzle solving. Especially in biology, there's a lot of different ways to approach different problems. But it just so happened that this fit perfectly. For example, there was the concept of trying to figure out the circuit. There was some math to be done to solve the different variables. And there was some esoteric equipment that I had to sort of put together in order to measure things. And I'm going to show you one example of some of the equipment that I had to put together because it's just so kind of comically complex. And that's exactly the kind of thing that Kuhn was talking about. Now, this video that I'm showing you, I didn't take in order to show anybody. I make videos when I assemble something that's really complicated so that I can go back later if I need to reconstruct it and see what I might have done in the past. Okay, so I was having fun designing different kinds of equipment and solving for one variable after another. And I'd actually solved for variables A through D, and I thought I could calculate the final variable. And then I realized, oh man, to actually know the total current through the circuit, I would have to offer the eel a target. And if I can take a measurement, I don't like to just guess at something, and that is why I offered an electric eel in my arm. Now, that first video that you saw was a preliminary test of whether or not current would flow through the device I constructed in the manner that I thought. And this is a theme in science that I'm going to talk a lot more about later, that experiments evolve over time often. And the next device that I built was the one for actually measuring the current. And I'll go ahead and show you the eel attacking my arm with this device because, you know, why not? Okay, so with that last experiment, I had my last puzzle piece. I was able to complete the entire circuit. That circuit can be extrapolated to other electric eels, other water conductivities, and so forth. I was ultimately able to publish those results in Current Biology, as it turns out, and some people thought that was supposed to be a pun, but there was no pun intended there. In any case, that's a victory in science. So publication is sort of the currency of the realm in science. It's one of the goals in science. And I hope this was an entertaining example of sort of a puzzle being solved. But now I want to leave off the details of, electric eels and these unusual experiments and the unusual biology of the animal, and return to the more general concept that often, many times, for an investigator, solving a puzzle in their particular area of expertise is what they're trying to do. And a puzzle can become an obsession, and that can be a great thing in science because it changes behavior. It makes you very motivated, and it also focuses your attention on a particular part of the world or on a particular problem. And then you may go on to design experiments, and those are also a means of further focusing your attention and bringing something into closer view. And I believe often those are the prerequisites for one of the most fun and often important parts of science, and that is making a discovery, finding something unexpected, often extraordinary, that you didn't even know was there. Now, there was no unexpected discovery in the puzzle that I just showed you, and that is a common outcome in science. So many puzzles get solved without making an unexpected discovery. But also, many puzzles are the gateway to discovery, and that often happens. And that's one of the things I'm going to describe next. And in the meantime, I'll leave you with some images of electric eels.